Unit 1, Prints, the language of industry. Drawings are used by welding industry to communicate ideas in graphic or picture form. Drawings are often the only means of showing the construction of a complex product and structures. Drawings are called the language of industry. It is a precise language that utilizes symbols. Symbols are lines and figures that have meanings to accurately describe the shape, size, material, finish, and fabrication of an object. The symbols are standardized and used as a universal language around the world. This standardization makes it possible to interpret and understand drawings made in other countries. Original drawings are seldom found on the job site or in a factory. They would soon become worn or soiled, making them difficult to read. Also, workers at different locations producing the various parts or sub-assemblies of the product or structure each need a set of drawings. This means that several sets of identical drawings are needed at the same time. Drawing a set of plans for each person who needs them is impractical because of the cost. Creating new originals to replace drawings that are damaged or ruined is also costly. Reproductions or prints of the original drawing or CAD model are used in these situations to ensure quality in the production and fabrication of parts. Version control of the prints is critical. Prints often will have a version or revision number that indicates the most recent print revision. Evolution of making prints. Before the development of computer-aided design or CAD systems, a high-quality original drawing had to be created. The original drawings needed dense and uniform lines for good reproductions. Manual drawing or drafting was an important skill used to create these drawings from ideas developed by engineers and technicians. However, manual drafting was time-consuming and editing required redrawing. Now, drawings are most typically created using the tools of a computer-aided design system. A CAD system is a combination of hardware and software that allows drawings to be drawn, viewed, and output printed or plotted electronically. CAD software programs provide drawing, editing, and dimensioning commands and other functions for use in developing original drawings. Manual drawing techniques are sometimes also used. However, the process is slower and less accurate than using a CAD system, and the quality of the drawing is dependent upon the drafter's technique. CAD systems. The growth in the computer field has had a direct and significant impact on the drafting field. The CAD system allows the designer to modify and manipulate the original drawing quickly. Instead of paper and pencil, the changes are made on a computer screen and saved on the storage media of the computer. The saved drawings may be transmitted electronically or retrieved and made into paper prints. CAD systems can be used to produce simple part drawings, but the modern CAD system is used to produce a complex three-dimensional model of a part or assembly. The drafter is able to design the part and then view it from all sides. Assemblies can be viewed to see if all the parts fit together properly, or the CAD system can be used to test the assembly for strength and proper operation. In some design phases, drawings of CAD models are used in the production of prototypes for testing and evaluation purposes. CAD drawing data is also used by machine tools for quality inspections and automated manufacturing applications. In computer-aided manufacturing, CAM, machining systems use information from drawings to produce parts and assemblies. In this process, data from a CAD drawing is calculated by the system in order to determine the movement and operation of the tools. To ensure quality, inspection of the part compares actual dimensions in the CAD drawing data. Printers and plotters. As computers become less expensive, so do the output devices attached to them. Personal computer packages are commonly purchased with a printer. In addition, the price of printers and plotters continues to drop as computers advance. Printers and plotters produce drawings that have dense lines and other features. Sometimes printing or plotting multiple copies is the easiest and least expensive way to reproduce drawings. However, in situations where dozens of prints must be made, using one of the printmaking processes is best. Inkjet printers are inexpensive devices that produce good quality output. Most are small enough to fit on a desktop. Many inkjet printers can print colors. Laser printers work on the electrostatic process. These printers typically produce a very high quality image. Many laser printers are capable of printing large size drawings while maintaining a high quality image. Color laser printers are common. Plotters are most commonly used to make paper drawings from CAD work. There are two types. Inkjet plotters are similar to inkjet printers, except they are used for large format prints. Pen plotters use pens to reproduce object lines. These devices duplicate the motion that a human hand might make while drawing. In other words, they draw lines instead of printing dots on the page. Pen plotters produce a high quality work, but they are fairly slow. Both inkjet and pen plotters are capable of color output. Older methods of reproduction. Tracings were commonly made by manual drafting when prints were needed. The first step in making a tracing is to draw the part on a translucent or somewhat see-through material. Many types of this material are available in sheet or roll form. Many drafters made original drawings on the tracing material that would be used to produce the copies. For more complex jobs, the layout was usually traced from the original drawing. This is where the term tracing comes from. Tracings and original drawings require a substantial amount of storage space. CAD drawing files are stored using electronic storage methods, which helps improve efficiency. What is a print? Print is a reproduction or duplicate of an original drawing. Basically, a print consists of the following elements. 1. Lines. Lines show part surfaces and points of machining. 2. Dimensions. Dimensions give the size of the part. 3. Notes. Notes provide information not given by the lines and dimensions. 4. Specifications. Specifications. Special notes for standards, type materials, or specific processes to be used. 5. Views. Views normally front, side, and top of the part. When several sets of prints are needed, the original drawings are reproduced or duplicated. The reproduction method must be quick and cost-effective, and must produce accurate prints and not destroy the original drawings. Why are prints used? It would be very expensive and impractical to draw a set of plans for each worker who needed them. It is also impractical to replace original drawings when they wear out or become damaged during normal shop use. Instead, reproduction techniques are used to make accurate copies of the original drawings quickly and inexpensively. These copies are usually called white prints or blueprints. In the shop, they are known as prints, drawings, or blueprints. Reproduction techniques. After the original drawing is completed, it may then be reproduced. As discussed earlier, tracing was one of the first methods to reproduce prints. However, now prints from CAD drawings and models are generated electronically by a computer. Drawings can also be reproduced by using xerography or making microfilm from drawings. Older printmaking processes employ a chemical reaction to produce prints. Xerography is a printmaking xerography. Xerography is a printmaking process that uses an electrostatic charge to duplicate an original. Xerography process is commonly called electrostatic process. This process is based on the scientific principle that like electrical charges repel and unlike charges attract. The electrostatic process exactly duplicates the original. A copy can be enlarged or reduced in size from the original if needed. Unlike older processes, the original drawing does not have to be translucent material. Large format engineering copiers can quickly reproduce from original drawings. Some computer networks are connected to imaging systems. These systems receive drawing information from electronic files created with CAD software or special graphics software. The imaging system is able to prepare the printing materials and control the size and resolution of the reproduction. Full color copies can be made on color copiers. This is an important capability in CAD drafting because color may be used on final prints to identify systems such as welds, wires, piping, and other materials. The microfilm process. The microfilm process was originally designed to reduce storage facilities and protect prints from loss. With this technique, the original drawing is reduced by photographic means to negative form. Finished negatives can be stored in a roll form or on cards. Cards or film are easier to store than full-size drawings. To reproduce working print, the microfilm image is retrieved from the files and printed onto photographic paper. Older printmaking processes. There are two older traditional printmaking processes, the Diose process and the blueprint process. As CAD drafting becomes more prevalent, more prints are generated electronically. This has caused a decline in the use of Diose and blueprint processes. However, you should be familiar with these two processes. Diose process. The Diose process is a copying technique for making direct positive prints. Positive prints are dark lines on a white background. The copies are produced quickly and inexpensively. In order to use the process, a tracing of the drawing must first be made on translucent material. The material is usually tracing paper on film. A Diose print is made by placing the trace in contact with light-sensitive paper or film and exposing them to light. Light cannot penetrate the opaque pencil or ink lines drawn on the tracing. Exposure takes place when light strikes the light-sensitive coating of the print paper. Print paper is developed after exposure by passing it through ammonia vapors. Where the lines prevent the light from striking the paper, blue lines develop on print. Blueprints. The blueprint process is the oldest of the techniques used to duplicate drawings. A blueprint has white lines on blue background. The process is similar to the Diose process. First, a tracing is made. However, the print must be developed, fixed in a chemical solution, washed, and then dried. The blueprint process is not used as much anymore. Many times the term blueprint is used to refer to any print. Electronic storage. Original paper drawings and prints were often stored in large drawered cabinets. Unfortunately, these drawings and prints were affected by light and dust, and they deteriorated over time. Many became unusable as a result. With the advancement of computer systems, reliable electronic methods were needed to store CAD drawing files. The first electronic data storage systems used a variety of magnetic systems, including moving tape and disk. However, static storage systems such as flash drives have become more common. Today, large amounts of data such as CAD files can be stored on a single small electronic device. CAD files are large and require specific formats to ensure proper storage, retrieval, and file exchange. There are many file storage and exchange standards. A few common CAD file formats include International Graphics Exchange Specification, IGES, Drawing Exchange Format, DXF, Stereolithograph, STL, and Additive Manufacturing File Format, AMF. Each of these file formats is used to move data from CAD systems to computer numerical control (CNC) machining tools, or 3D prints. Through file exchange, CNC machines or 3D printers can produce parts from the CAD model. Importance of prints to welders. Prints have special importance to welders. They show where and how the various components to be welded fit together. Prints provide the welder with all the information needed to make the welds. Information may be included in the following: welding process to be used, welding size, weld type, type of filler metal, how the weld is to be finished, and other pertinent data needed to make welds meet design specification. In addition to having welding skills, welders must know how to read and interpret prints. Otherwise, there is little chance the welds will be made to specifications. The inability to read and interpret prints can result in higher cost parts because more welding was done than necessary. Unsafe or dangerous welds are possible since incorrect print interpretation could result in a weak or rejected welds that do not meet design specifications. Care of prints. If given proper care, a print will have a long, useful life before it must be discarded. The following is a list of precautions used when handling prints. 1. Keep prints clean. Avoid setting food or drinks on prints. Dirty prints are difficult to read and can cause errors when welding. 2. Avoid tearing prints. Fold and unfold prints carefully when you use them. 3. Avoid laying tools and other objects on the prints. 4. Do not make revisions or changes on a print unless you have written authority to do so. 5. Some prints are concerned with work that is secret or classified in nature. Handle and store these prints according to company and agency security policies. Penalties for ignoring security precautions can prove costly to you. Welder certification. Qualified welders can prove their skills by taking a welding certification test. Welding certification tests may be developed by individual companies or may follow the National Welding Code specifications. Although there are many worldwide welding codes, the two major welding codes followed when certifying welders in the United States are the American Weld Society (AWS) D11 Structural Welding Code for steel and the AMSE American Society of Mechanical Engineers Section 9 of Boiler and Pressure Vessel Code. Welding certification tests are similar but not identical. Each limits the welder's certification depending on the welding process used. For example, shielded metal arc, gas metal arc, etc. The material used, carbon steel, aluminum, nickel, etc. And the position of the test, flat, horizontal, vertical, overhead, pipe axis positions, and the structure used, whether it's plate or pipe. Test welds are usually destructively tested or bent, and specific acceptance criteria is used to evaluate the bend test specimen. Upon successful completion of the test, the welder receives documentations or certifications indicating the limits of the certification. Preparation for certification. Preparation is key to successfully completing a welder certification test. Often high schools and community colleges teach preparation classes. Whether you take a preparation class or practice for a welder certification test on your own, many hours of practice are required to ensure your success. Entry-level welding. For a successful career, an entry-level welder may need knowledge of welding technology in addition to the ability to make quality welds. In addition to the ability to interpret prints and welding symbols, welding technology knowledge may include an understanding of welding processes, metals, and their uses, welding equipment operation and maintenance, and cutting processes. Some of the classes needed are part of the standard coursework at the school, but the American Weld Society has developed a standard to aid and the instruction of both welding knowledge and performance. This program, which is called SENSE, Schools Excelling Through National Skills Standard Education, allows students to develop welding knowledge and welding skill through compliance with key knowledge and performance indicators developed by industry experts. Successful completion of both knowledge and performance tests are required by the AWS SENSE program to receive a credential. The performance tests are identical to the AWS certification tests, and therefore successfully completing the SENSE performance tests will provide your ability to successfully complete the AWS certification tests.